This video is going to talk about least common multiple. The least common multiple is when you have a set of numbers and you're trying to find the smallest number that all of those numbers will multiply into. So this might be a problem about an event that's happening or will be repeating over and over. It might be talking about getting multiple items in order to have enough, which is going to be our first example. Or it might be talking about figuring out when something will happen again at the same time. So, for example, let's say that trading cards are sold in booster packs of 9. And let's say that card sleeves, which are the sleeves that protect the cards, are sold in sets of 21. Well, you want to have the same number of card sleeves as you do cards because you don't need any extras. So the question is, how many sets of card sleeves and cards do you need to get, and how many total cards and card sleeves will you have? So to figure this out, you know that the cards are set in groups of 9, and you know that the sleeves are set in groups of 21. So the first thing that we want to do to figure this out is we want to make a factor tree of each number. So let's make a factor tree for 9. 9 breaks down, two numbers that multiply into 9 are 3 and 3. And we know that 3 is prime, so we're just going to end our factor tree there. And then we want to do the factor tree for 21. So 21 breaks down, two numbers that multiply into 21 are 3 and 7. 3 is prime, and so is 7. So, now that we have all of our factor trees completed, what we're going to do is we're going to list those factors. So the factors for 9, there's a 3, and then there's another 3. And I don't just want to put 3 and 3, I want to make sure I put a multiplication sign in between so I know that it's not 33, because that would be a problem. What we're going to do now is we are going to create little cages for these 3, kind of like little apartments. And in these apartments, you can put another number of the same type, but you can't put a bigger or smaller number. And the way I like to think about this is that if you put a bigger or a smaller number in there, then the bigger number is going to eat the smaller number. Does that actually happen? No, but it's just something that helps me remember. So when I take the prime number for 21, when I take that 3, I can put it in this little apartment cage right here because 3 and 3 are the same number, everything's fine. But this 7 can't go in the same cage as a 3. It has to go into a different cage. So now that all of my prime factors are set here, I'm going to close the doors. In this cage is 3s. Doesn't matter how many there are, this is a cage of 3s. This is a cage of 3, and this is a cage of 7. So what I'm going to do now is multiply. 3 times 3 is 9. Bring down the times 7. 9 times 7 is 63. So what that means is that if we buy enough cards and card sleeves, the least amount of cards and card sleeves we have to have in order to have the same amount of each is 63, which is a lot. But let's do another example problem, only this time let's do it with 3 numbers and let's see how that works out. So, for example, let's say that we have the number 4, which is off screen so you can't see that. Let's say we have the number 4, the number 6, and the number 8, and we want to figure out the LCM for 4, 6, and 8. Well, in order to do that, we have to do a factor tree for each. So I'm going to break down 4. What two numbers multiply together to make 4? Well, I know that it's 2 times 2. Break down the 6. What two numbers multiply together to make 6? I know that that's 2 and 3. And then to break down the 8, I know that 2 times 4 is 8. 4 doesn't get circled, 4 is not prime. I need to break down 4 even more before I can reach the end of those particular branches. So now that those factor trees are done, what I'm going to do is I'm going to list the numbers, I'm going to put them in their nice little cages again. So for 4, we have 2 times 2. For 6, we have another 2. Oh, I should have been marking those off so I know to keep track of them, but the numbers are, there's so few factors that it's hardly necessary right here. This 3 can't go underneath the 2, it has to go in its own section right there. And then we have for the 8, we are going to list the 2, which can go here, and then this 2 can't go here, can't go up here because that's the 6's spot, so it has to go off on its own over here. Which means that when we make those cages, this door should be labeled 2 because there are 2's in here. This door is also 2, this door is 3, and this door is 2. Now, when I multiply these numbers together, slight shift, let's hope my tower doesn't fall down. 2 times 2 is 4, bring down the 3 and the 2. 4 times 3 is 12, bring down the times 2. 12 times 2 is 24. So the smallest number that each one of these 3, the 4, the 6, and the 8 multiply into is going to be 24. Now, the question for you that's going to be on the form is, what about the numbers 12 and 6? And you'll see that on the form, but you're going to be asked to figure out the LCM for 12 and 6.